Please pause the video and read the problem. Alright, let me explain this example. First, please tell me how many major events are here. There are two major events. I can define them. A. Policyholder has an accident. B. Policyholder is accident prone. This example explains mainly two groups of people. What are the two groups? Accident prone driver group and non-accident prone driver group. Okay, now let me write down given information. The probability an accident prone driver has an accident is 0.4. Here is the probability has an accident, but they talk about the one group, an accident prone driver group. So we know these drivers are coming from the group an accident prone driver. Therefore, it is a conditional probability. Again, they are talking about the probability of accident, but only an accident prone driver group. Therefore, probability of A given B equal 0.4. Next one, the probability a non-accident prone driver has an accident is 0.2. Similarly, they talk about the probability of accident, but this time they talk about the other group. What is the other group? Non-accident prone driver group. So we know the event, we define B, it is the accident prone driver group. Then how do we define non-accident prone driver group? It is a B complement. Therefore, we can write this probability of A given B complement is 0.2. The last one, the population is estimated to be 30% accident prone. That means probability of B is 0.3. Right. Now let me explain this using a Venn diagram. As I mentioned before, this example talk about only two groups of people. So our sample space must be the all people. And there are only two groups of the peoples. What are those two groups? B, accident prone group, and B complement, non-accident prone group. Right. Now think about A. How do we show event A in this Venn diagram? So A is the policyholder has an accident. Yes, it is clear there are some drivers who has an accident in group B and also group B complement, right? So there must be drivers who have an accident in both groups. Therefore, we can represent A like this. So A has two major parts. What are those two parts? First one, A intersection B, and next one, A intersection B complement. So you know these two events, A intersection B and A intersection B complement, are disjoint. Okay, now let me go to the part A. What is the probability that the policyholder will have an accident? Right. Now they are asking probability of A. So how do we find the probability of A? By the law of total probability, we can write probability of A equal probability of A given B times probability of B plus probability of A given B complement times probability of B complement. So let me explain this using this Venn diagram. So as I explained before, we can write A intersection B union A intersection B complement. So it is clear from the diagram. Right. Now we need to find the probability of A. And as I mentioned before, we know A intersection B and A intersection B complement are mutually exclusive events or disjoint events. Therefore, when we apply the additive law of probability for the left side of this second formula, the intersection of these two events must be 0. Probability of the intersection of these two events must be 0. Therefore, we can write probability of A equal probability of A intersection B plus probability of A intersection B complement. But you know the conditional probability formula, that is probability of F given R equal probability of F and R divided by probability of R. Now think about probability of A and B. So I write probability of A given B. So how do we write probability of A given B? Probability of A given B equal probability of A and B divided by probability of B. From that, you can write probability of A and B equal probability of A given B times probability of B. Similarly, you can do the same thing for the probability of A and B complement. So applying that, we can write probability of A equal probability of A given B times probability of B plus probability of A given B complement times probability of B complement. So that is the by the law of the total probability, right? So that is the one we write here. But here we know probability of B, but we don't know probability of B complement. So how do we write the probability of B complement? That is 1 minus probability of B. So now we know all the probabilities. Just plug this and get the probability of A, which is 0.26. Now go to the second part, part B. If a policyholder has an accident, what is the probability that he was accident prone? So write down this using events A and B. So here asking what is the probability that she or he was accident prone. That means probability of B, right? Asking probability of B. But there is a condition. What is the condition? If a policyholder has an accident. That is a condition. Therefore, we can write probability of B given A is the probability they are asking. So how do we do that? And you know this, probability of A given B equal probability of A and B times divided by probability of B. So for our case, we can write this. And we don't know probability of B and A, but we know probability of A given B. So using that, we can write probability of A given B is probability of probability of B and A can be written probability of A given B times probability of B. So now we know all the probabilities, plug them, get the probability of A, which is 0.462.